Hi, I'm Alan Ross. I'm the managing editor of APC Media, or APC Technology Productions, Transformer Technology, Power Systems Technology. We are here at the RE Plus 2023 event in Las Vegas. This thing is huge. It seems like the battery storage people have come here. So we've got wind, solar, battery storage, and everything in between. But hope you enjoy these interviews. I love interviewing the technology of the future, and enjoy. My next guest is Ann Will.
Hi there.
Ann is the founder and CEO of a company called Groundwork. Very fascinating what you do, and I really appreciate it. But before we get to what Groundwork does, I want to talk about what you've been 14 years, you've seen a lot of change in the industry, especially in the solar industry, right?
Yeah, we've been in business since 2009, so.
That's a long time.
Yeah.
I mean, that's you're now the company that is a really old company.
Exactly.
You've been doing this a long enough time. So what have you seen changing over time? And now this pace of change seems to be picking up.
Yeah.
Talk to me about what you see in the industry.
Yeah, so we're exclusively focused in the utility scale solar sector. And one of the things I like to say is there was 0 gigawatts of utility scale solar when we founded the company. And this year we're hitting, I think at the end of 22, 68 gigawatts.
Okay.
So kind of 0 to 60, kind of analogy. And then this year we're in the 20s and expect to be installed and commissioned. So that's, like, as you said, picking up the pace. It's a third more than the entire previous installation base. So that's a significant thing, and it's only going to increase from there. And to be able to put that together in that many plants being built in a single year across the entire country, they're bigger plants, bigger construction teams, new market entrants, new developers, new constructors. You get a lot of new to go with this company that's been around for 14 years. So it's a lot of kind of teaching that goes into that, and people coming into it from oil and gas, people coming into it from the oil majors, wind entrants coming into solar. So just getting everybody up to speed so that we can all kind of march at this very fast pace, right? So.
Yeah, I think we've come to the point that people no longer question whether solar can do it. At this, I mean, I've been doing RE Plus for a while. It seems to be a very heavy emphasis on batteries. I mean, like the second floor up there is all batteries and storage. And we're talking about big scale type things. So,
Well, with battery being able to firm the power from a solar plant, it's going to increase the proliferation of solar even further. And I like to, the term DG versus utility scale solar, but I still think of utility scale solar as being a distributed resource, right? Because it's all over the country. It's in the southeast, it's in small towns, it's in Kentucky, it's in the northeast. It's a unique situation to have.
We talked to a couple of industrial companies, large industrials, who depend upon power and the fear that the grid can't support what they need, and they're putting in these unique microgrids where they have wind and solar right near their factory, and then how do they integrate that into the system? Very complex decision. So that's another growth area.
Well, that's hybrid solutions, but it's also, you're talking about another thing. You have, the transmission bottlenecks that we're seeing in utility scale solar, especially in the eastern United States. So the ability to, directly take your power from your plant, obviously, is a way to get around that. And then you have companies, large independent power producers, that are funding transmission lines to get more solar built. So everybody's doing, I think, everything they can to get more deployed.
So I think I wouldn't say we've solved the transmission line problem, but we're we're farther along the way.
Made some progress.
Then we have a lot of problems in the distribution lines, right? That's where a lot of the struggle comes in for utilities. And we're solving that. The other one I think we've solved, now we got to scale. This one we're trying to figure out how to solve it. Other things that you see maybe out of your space in the industry, what's happening?
Just, we're still seeing, the technologies are getting more, not less, right? So the standardization really isn't there yet. I liken utility scale solar to like custom house builds, right? Like, one's a French chateau, the next one's like an Italian palazzo, kind of like our strip here. But so every project is pretty custom and pretty different. So that's an area where we come in and have to kind of take that into consideration when we're instrumenting the plants and make sure that so I think the more that we drive towards standardization, is the next wave, right? Now we know how to build it. We're all building it in different ways. You're seeing a lot of tracker manufacturers come into market, a lot of inverter players, right? And so, but the more we move all of that towards a standard plant, the more that we're going to be able to get built, right? And also get built and maintained successfully, right?
I'm a reliability engineer, and standardization is good for us.
Yeah, of course.
Anything that's too flexible, you go, that's not reliable. Yeah, that's right.
Yeah.
I want to go specifically to Groundwork and what you all do. It's very unique, and I asked the question of somebody in your company, but there's so much weather event happening. How in the world can you give people good information about the ground they're about to put a solar plant on? Talk to me about.
So you measure it.
Sell me. Sell me as a customer.
Yeah,
how does it work?
Yeah. So what Groundwork does is we take measurements, in situ measurements, reference solar measurements. Irradiance is our sunlight. That's the fuel for a solar plant, is the sunlight, right? So plus temperature, all the variance, wind speed, wind direction. We measure albedo for bifacial modeling. We measure soiling rates for looking at what type of soiling losses that you'd have when you build a power plant. And we take it when it's very early, just in the greenfield development of a utility scale solar plant. And we do it for 1 to 2 years, and we QC the data, meticulously, so that it's really can go into a financing process and be a gold standard for what you would expect your energy production to be. So it's an input into the models for the energy production assessment for the utility scale solar plant. And that hopefully is going to get better financing, better terms, and then it gives that owner some certainty around what they're going to expect in terms of output. And then the next thing we do is we actually supply the MET systems for those exact same owners into the operating plant. So once you're in operations, you're comparing plant output to models, and by having measurements, that then provides the model that you're comparing against. So,
you do something with satellites too.
On the resource assessment side, in the pre-construction basis, our ground data is tuned with the satellite data, so that they can look at all the weather across all the years. That's all the in the past, and that then is how you can run different scenarios for what your expected output would be.
And how many years do you look at?
So satellite data can now go back, 25, 30 years, but we're taking measurements for a 1 to 2 year period. And that's extended. With the larger project sizes and also just more visibility into the developer's pipeline, we're able to take measurements for a longer period of time and get more certainty for the owner.
Okay. There are weather events we hear of now that you can't take into account because they are unique. California had storm after storm after storm, which meant cloud after cloud after cloud. Do you have any way of taking those unique weather events into account, or is it just guesswork?
What we're there to measure when the event happens. So, a good example would be hail in Texas. Maybe you've been familiar with some of our, trials and tribulations around that. But the ability for us to be a measurement so that you can see, hey, was this plant stowed, and did they then prevent losses, right? When a hail, but you actually have to have measured that there was hail at the time, right? So that's where we are. We're kind of in there as that reference data that can inform the insurers, the owners, the warranty claims in the case of wind events. So all of those variety of things. We're that
You're the gold standard of should I build it? Where should I build it?
Not the where should I build it. More just the certainty with which you would expect the output to be. Generally, the where should I build it is much more around transmission and who the off-taker is and all of those types of
and land acquisition, et cetera.
There's a whole sort of things to go with that.
At utility scale, the next thing, and this is not maybe Groundwork's expertise, but it is the next thing that and we talked about it when I said there's a lot of battery storage here at RE+, is we're learning now how to store wind and solar which is the next big breakthrough. That's where scale comes. That's where utilities can go, look, I don't need gas peaker pants anymore because I got this, whether that's flow batteries or whatever kind of thing. Talk a little bit about what you've seen at this event.
Yeah, I'm not as familiar on the storage side. It's not really where the measurements they're not as concerned about the weather. So I really can't comment on that.
Okay.
Yeah.
Go upstairs, spend about 30 minutes walking around, come back down and tell me about it. I want to talk about one more thing. Women in power systems. You are unique. Number one, you're a founder and a CEO, and you're a woman. We publish twice a year a magazine called Women in Power Systems, and it is the story of how you got into it, why you got into it, and the uniqueness of being a woman, number one, in business, and number two, being a founder and being in the power industry. How did you go about getting into it?
Yeah, I was running operations for a non-renewable company, and so I was always in a leadership and executive position through the 90s and early aughts. And but my dad had had a bit of an entrepreneurial spirit, so I think he kind of instilled that into me. I always thought I could run a business, and I don't know why I thought that. But yeah, so we started in. I felt like I could make a business out of this type of work. We had a single client at the time and a partnership with the National Renewable Energy Laboratory.
Oh, okay.
And so that's how we got in so early with these measurements, and also got a really good understanding of how to take high quality measurements and the importance of quality. Otherwise, you really shouldn't take measurements if you don't have high quality measurements, to be perfectly honest. And what's been, I think, the neatest thing about being a woman in business, because I've never really looked at it that way, I just think of me as Anne. But I really have been able to hire a lot of fantastic women into leadership within our company, and they're all technical and business savvy, and just they represent. So it's pretty fun when Groundwork goes to an event or a party, because pretty much the number of women at that event or party is going to double. So yeah, in this industry, and it's certainly more and more women every day in solar and in engineering, and certainly we encourage that.
And what I have found, and of course I find this as a man, but there is no block to the women that want to come into this industry. It's not a natural block. It's not like, oh, you're a woman, you can't come into this industry. A male-dominated industry that is desperately looking for the next generation. Yeah. And I would hope that that's the next generation of men or women that are coming into it, but especially women. I'm very heavily involved with the Perkins Act, which created STEM for education for high schools, a $5 billion expenditure. It was the only thing that was unanimously passed during the Trump administration, unanimously from both houses, and signed by Donald Trump. The only thing. And it was because we said, look, we've got to train up the next generation of STEM, both women and men, but we were really at that point realizing we have this gap, and you filled that gap 14 years ago.
Yeah, exactly. I got to fill it. I find it's my daughter's 14, and her, she loves math. And one of the things I was reading, that one of the things they say about girls and math is that English or reading comes more naturally to girls. They're actually really good at math. It just seems easier to do reading, and so then they assume they're not good at math. And my daughter had a math teacher that was a woman last year, and she said, "I'm here to teach girls to love math." Right, like one of her, and I think that's just also just having that mindset of, hey, I'm good at this, I can be good at this. So, and I think that gets you in the energy industry, and certainly we work with a lot of amazing female performance engineers at our clients, with our clients, and it's so cool to see.
So, and on the APC technology side, transformer technology, power system technology, we have a technical advisory board.
Okay.
That is somebody who's technically savvy about a section of the industry. I would like you to join that as it relates to renewables, because that's something we really want to focus on.
Yeah.
But it also, it allows or asks you to find participants for any part of what we do, women in power systems particularly. So I'm putting you on the spot in the interview to say, would you be part of that? It's easy. It's just a matter of connecting the right women with our managing editor and going on from there. But
happy to support.
Thank you so much. It's been a delight.
Hope
Good
that
luck.
worked out.